Hi, this is Chris, CSJ Code from systemsarchitect.io. Thanks for checking out this video on our data encryption best practices checklist. Encryption is the last line of defense when firewalls, IAM, and network segmentation all fail. If stolen data is ciphertext, the breach is painful, but the payload stays unintelligible. Cloud platforms make encryption easy to turn on, but keys, algorithms, and certificate lifecycle are what separate checkbox crypto from real protection. This checklist covers 10 practices for encryption at rest, in transit, and key management across AWS, Azure, and Google Cloud. 1. Encrypt at rest by default. 2. Encrypt in transit everywhere. 3. Force TLS 1.3 minimum. 4. Use mutual TLS internally. 5. Rotate certificates automatically. 6. Pin certificates when required. 7. Classify data before encrypting. 8. Use separate keys per workload. 9. Enable key versioning. 10. Destroy keys when no longer needed. Use this when you harden a landing zone, close compliance gaps, or clean up half-encrypted estates. First, encrypt at rest by default. Turn encryption on at account or organization level so every new volume, bucket, disk, and database is encrypted without human memory. I should mention, this presentation is a condensed version of the complete article on blog.systemsarchitect.io. View the full blog article with more details there. One unencrypted EBS volume or snapshot is the weak link. S3 encrypts new objects by default, but many other services still need explicit config. Elastic Block Store is a AWS block storage service for EC2 instances, volumes, and snapshots. Deny unencrypted creates with SCPs or Azure policy, and use organization constraints for CMEK when required. Service control policies are AWS IAM policies used at the organization level to enforce rules like denying unencrypted resources. Customer managed encryption keys are encryption keys fully controlled by the customer rather than the cloud provider. AES 256 with hardware acceleration is usually under 2% CPU and often noise in benchmarks. On AWS, enable default EBS encryption per region, encrypt RDS at create time, and force encrypted volume creates. On Azure, storage and SQL TDE already encrypt. Upgrade to customer managed keys in Key Vault for regulated data. Transparent data encryption is an Azure SQL feature that automatically encrypts database data at rest. On Google Cloud, everything is encrypted at rest by default. Add CMEK where you need customer control. Detective scans for unencrypted disks are useful, but prevention at create time is what stops the gap from opening. Second, encrypt in transit everywhere. Isn't internal traffic already safe? Private VPC traffic is not automatically safe. Compromised hosts can sniff, and databases, Redis, Kafka, and internal HTTP often default to clear text. Enable TLS on every hop and prove it with connection settings or packet captures. On AWS, force RDSSL. Set Elasticache in transit encryption at create, use HTTPS target groups, and rely on Nitro instance encryption between modern instances. On Azure, SQL and Redis support TLS. Set minimum TLS, HTTPS only app service, and private endpoints on the backbone. On Google Cloud, require SSL for Cloud SQL, encrypt memory store in transit, and use Istio or Anthos Mesh for automatic MTLS on GKE. Google Kubernetes Engine is Google's managed Kubernetes service. Third, Force TLS 1.3 as the minimum when you can. 1.3 drops weak ciphers and handshakes, keeps only AEAD suites and ephemeral key exchange, and is faster by about one round trip. Fall back to 1.2 only for clients that truly cannot speak 1.3 after you check load balancer negotiation logs. Most modern browsers and runtimes already support 1.3. Holdouts are old IoT and some enterprise proxies. ALB and CloudFront security policies, Azure Front Door and Application Gateway, and GCP restricted SSL policies all let you raise the floor. Zero RTT resumption can speed repeat connections, but treat it carefully because of replay risk on sensitive actions. Fourth, use mutual TLS internally. What's wrong with standard TLS alone? Standard TLS authenticates the server only. Any client that can reach the port can talk. MTLS makes both sides present certs, so stolen network position is not enough without your internal CA-issued identity. Do not wire this by hand for every pair. Use a service mesh with strict MTLS, short-lived certs, and sidecars. App Mesh with Envoy, Istio Peer Authentication Strict, and Anthos Service Mesh or Traffic Director cover ECS, EKS, GKE, and beyond. Fifth, rotate certificates automatically. Expired certs take HTTPS offline instantly. Manual renewals fail when people leave or calendars slip. Use managed certs first. ACM free public certs, App Service managed certs, Google managed load balancer certs. For the rest, Cert Manager or Vault PKI plus 30-day expiry alerts and periodic OpenSSL end date checks. Public key infrastructure is the framework for managing digital certificates and public key encryption. Private CA short-lived certs fit MTLS rotation well. Mesh defaults often reissue about every day. Sixth, pin certificates when required, not everywhere. Pinning ties clients to a public key so a bad CA cert cannot MITM you, which matters for banking, health, and high-assurance mobile apps. Subject public key information is the part of a certificate containing the public key used in pinning. It also makes rotation harder, so pin SPKI hashes always keep a backup pin offline and ship pin updates in the app. Not a remote config attackers can poison. Subject public key information is the part of a certificate containing the public key used in pinning. HTTP public key pinning is a deprecated header for pinning certificates. Treat HPKP with extreme caution. Misconfig can walk users out. Prefer MTLS to API gateways with trust stores when bilateral auth is the real goal. Seventh, classify data before encrypting. Why not one key for everything? One master key for everything means one compromise decrypts everything. Tiers match cost and control to risk. Map public, internal, confidential, and restricted to provider keys versus CMK, logging, HSM backing, and break glass only access. Tag resources by classification and policy check that encryption matches the tag. Macy, Purview, and Cloud DLP help discover PII and secrets so labels are not guesswork. Over-encrypting public junk with HSM keys wastes money. Under-protecting restricted data is the real risk. Eighth, use separate keys per workload. 8 keys should not also encrypt profiles and analytics. Separation limits blast radius, supports different rotation and audit, and helps PCI-style isolation. Key per major workload, not per single bucket to avoid sprawl. one CMK shared by that app's database, storage, and queues. Name keys clearly, tag ownership, and grant encrypt and decrypt only to that workload's identity. Ninth, enable key versioning. Rotation without versioning forces mass re-encrypt of historical data. With versions, new writes use the latest key and old ciphertext still decrypts. Turn on automatic annual or policy-based rotation in KMS, Key Vault, and Cloud KMS so apps keep the same key ID or alias. Alert if too many active versions pile up, which can mean old data never re-encrypted. Batch re-encrypt when compliance demands it. 10th, destroy keys when no longer needed. Does deleting data actually remove it? Deleting objects does not erase every snapshot and backup. Destroying the key crypto shreds all copies you no longer control on physical media. Schedule deletion with the cloud waiting window. Disable first, watch for broken apps, then let purge complete, and log it for governance and GDPR style erasure proof. AWS KMS pending deletion. Azure soft delete, then purge with purge protection, and Cloud KMS version destroy with restore windows all support this carefully. Document who authorized destruction and when, so auditors can tie crypto shredding to data retention policy. To close, default at-rest encryption and everywhere in transit TLS close the most common exposure paths for almost free on modern hardware. Raise the bar with TLS 1.3, internal MTLS, and automated cert lifecycle so outages and weak ciphers fade. Classify data, separate keys, and version them so risk, cost, and rotation stay manageable. Destroy keys when workloads die so unrecoverable really means unrecoverable. Do those 10 practices and encryption becomes a real last line, not a checkbox. Thanks for checking this out. Hope you learned something. Find a lot more articles and guides on both systemsarchitect.io and codeguides.io.